Hello again, 108 students. Mr. McHugh here, back with you on section 2.7. Gonna wrap up the page 3 here. Well, not wrapping up, I'm sorry, we got another page to go afterwards. But we're gonna now work with objective number 4, and this one here is pretty easy. All they're doing here is going to give you an inequality, and again, if this is an equal sign or less than or greater sign, it doesn't really matter. What they're trying to trick you here, it's not even tricking, I'm sorry. They're adding what happens if it's not just the absolute value on the left hand side. So guess what you're going to do? You're going to take the other term, a constant, move it over to the other side by minusing 5 and leaving yourself with absolute value of x plus 3 equals 7. Now once you do this one fairly easy step, you're back to review material from the beginning of this section. And again, whether it's equal sign or greater than or equal to, you simply got to remember the key concept here is inside the absolute value chambers. That's just my nickname for it here. I do the idea that if you have a magic trick that whatever you put inside, the old bunny goes inside the hat, and when you drop the sides of the box, what comes out? Nothing. And with the trick with the bunny. So the idea here is no matter whether you put in a positive expression or a negative expression, you turn around there, the absolute value signs are gone, the chamber's dropped, and you evaluate. So you do this simple algebra, x equals 4, watch the distributive of the minus signs. Don't forget, if you ever divide or multiply by a negative number, you're going to switch the signs, and then you're going to graph like we did before. Okay, so that's pretty easy. That's not too much going on there. I look at objective number 6 here now. What they're having us wanting to do is deal with special cases. This is where you got to be on your A game thinking here a little bit, and I just want to point out one more time, absolute value is, I use this example that here we are at CWI at main campus, and somebody lives 5 miles this way going west towards Meridian. Somebody lives 5 miles, that's east. Here's east. West would be in Nampa, 5 miles. On a number line, we have to put a negative or a positive, and here's Nampa. And two students, they get in their cars and they drive to the campus. And I'm just reviewing what I'm talking about absolute value is. And so on their odometers, what happened? No matter what direction you came from, you drove a positive 5 miles. Okay, thus the negative case and a positive case of the absolute value chambers. So I'm trying to get to the point crossed here is this special case is if you see absolute value, you must always have the result has to be, and think of result going this way, has to be greater than 0. You have to have a positive number. Okay, so what are you going to do if you jump down, you look at this example real quick, and you see absolute value 5r minus 3 equals negative 4. And before you start writing two separate cases of positive negative, stop. What is the result on the right hand side? It's a negative. Can that be? Can the result of absolute value ever be negative? No. And so you get the stop, and right, it's the null set, and you can use the symbol that I've got here like that, and you're done. No work needed. There's the thinking problem there. I like those. You catch those, you save yourself a lot of save yourself a lot of time and frustrations. Okay, second case. This one seems kind of obvious. Absolute value, if the expression is 0, then the result is 0. And so what I'm trying to say here is if you have the absolute value of an expression inside and it equals 0, inside that expression has to be equal to 0. So if you come down here and look at this example, start off absolute value of m minus 7 plus 4, so you go, oh, it reminds me of the objective up top of the page, add 4 to both sides. Absolute value of m minus 7 is less than or equal to 0. Okay, so now what you got is the result has to be 0, which is not a negative, but what value does m have to be? Take the expression m minus 7, set it equal to 0, and solve for m. And I'm running out of space here. Add 7 to both sides, and m equals 7 is your solution set. Okay, so just keep those two little special cases in mind. Just a fast review. You must always have a positive value as the result of an absolute value. If it's ever negative, it's a null set. You can stop. If you ever have the absolute value turns out to be equal to 0, set the expression equal to 0 and find the value that makes that. So if you say 7 minus 7, do you get 0? Yes, and that's the solution. Okay, hey, that's going to be here for page 3. I will see you for page 4, finishing up the last page of our yellow notes here. Okay, I'll catch you later. Bye.